with Rangvien to share a presentation and proceed. Thank you.
Can everyone see my screen?
Sure.
All right, I'll get started. Hi everyone, I'm Ha. I'm a PhD candidate in STEM education at UC Irvine, and today I'm really glad to be here and talk about part of my dissertation looking at group discussion with conversational agents or text-based chatbots in this context. So we're just going to quickly go through the background, meet the two chatbots, go into the studies, and then a little bit of discussion. And if I had 15 minutes instead of 10, so Rogers, please remind me when the time comes. So just a little bit of context for this project is based on a long-term partnership with a local nonprofit, education nonprofit in Orange County, California. And the idea of the nonprofit is that they bring students from elementary, middle, and high school to the state park, Crystal Cove, to collect data, try to come back to the classroom, analyze data, build models, and present the data to biologists at the state park to answer questions such as whether the marine bioconservation area there really helps with biodiversity, or how they're using decomposition is helping with the restoration effort. And so within this long-term partnership, the curriculum we work with is with high school students that really try to help students think through how elements within the marine ecosystems are connected, and how efforts going on at the state park can facilitate these efforts. So usually when you tell students to talk about, like, can you think of any things in the ocean, they will bring to you really simple linear links. So they might say something like, oh, I know that like fish eat planktons or whales eat fish, but really we want to make them think more coherently about the underlying processes that link all those things, and also to the feedback loop. So for example, between regulation, overfishing, phytoplankton, and then larger biodiversity and habitat issues. So when we present this in the classroom and have students work in groups together on these ideas and construct a concept map together, they're engaging in knowledge building processes where they're building on a shared artifact and building on one another ideas. We're also engaging them in causal reasoning, where they think through elements within the systems to use evidence to support their thinking, and also try to bring in causal coherence to link every pieces of information together. And then as students are building on one another's ideas, they're also engaging in transactive exchange, meaning that they're using reasoning, but building on previous ideas that they articulate by themselves or a peer in the group has articulated. And these three processes are all really important for learning because they help learners as a group construct more coherent knowledge over time. So how can we skip over these processes of knowledge building, transactive exchange, and causal reasoning? Prior work has used modeling or simulations. They have also used these pedagogical agents, so agents within the learning systems that can give hints or feedback to the students. And then for collaborative context, also embedding the agents in the group chat so that the groups are working on the left here, but then the agents are also monitoring the conversation and giving prompts for discussion on the right. Researchers have also looked at using designs to try to bring adapt to learners' preferences. And here are examples of using different roles like experts, motivators, and mentors, and also adapting the gender, race, and ethnicity of the pedagogical agents to students. And these are all based on the ideas that computers are social actors, meaning that learners or users subconsciously enact social conversational norms with the agents in conversations, and those may be beneficial for learning. But when we bring these designs of the agents into groups, we know that group knowledge composition may also influence how people interact. So let's say like I bring an agent, a peer agent with life knowledge in the group. Those with different knowledge levels may show different help giving and help seeking behavior spontaneously in this group. So bringing it all together, we know that learners engage socially, emotionally, and cognitively in collaborative learning environments, and different group dynamics can influence interactions with one another and with the tools. Knowing that when we represent different design paradigms for our agent or chatbot in these conversations, we may see that collaborative discussion patterns may vary with these conversations. And then even within student groups, because we know that students may interact with these agents differently, we're curious to understand how these patterns may differ when they're talking to a peer versus an expert agents. And if these are all like really vague right now, well, just go in and meet the agents really quickly. So this is a chat interface. And basically what students are doing is they're in group 3 or 4, they're in the chat on the right. And then as they're talking to each other, the chat is getting parsed to build the concept map in the left from the sentences they put in the chat. So let's first meet with the expert agents. And so now I'm just going through introducing itself as someone that has been trained to understand marine science concepts, and then it's just giving the rules. But like you can see that the students are inputting different sentence structures and it gets parsed into the concept map on the left. So here's from the perspective of a student filming the chat. And then, for example, Kevin here say that sharks eat fish, but the system is comparing it to the underlying map and correctly understood it as predators eat fish. So within this context, students can also ask the bot to define certain concepts, like for example here, looking at defining biodiversity. And then the bot is also giving hint for students to think about missing components in the system that they haven't mentioned. So what about decreasing phytoplankton and helping students build the concept map over time? The peer bot gives similar hints, but it has a different background story as someone who has never been to the park and is learning with the students. So it's really trying to like bring in the emotions and the effective responses, and also like bringing students into the conversation, for example, calling on user ID and ask them for their participation. So in some, they give equivalent hints, but they have different designs and different effective visual expressions and also different text to prompt students. So within this study, it drew from a larger sample of 52 students divided into 18 groups, taught by the same science teacher in 9th grade. So the procedures is students did the pre-test and then they're randomly assigned to talk with one of the bot. So either the peer or the expert switched halfway through and then took a post-test. And then the pre-tests were coded based on our theoretical framework of causal reasoning. So for element evidence and coherence into low ability, mixed ability, and high ability groups by the scores. And then I randomly sampled to one group from each of these bigger categories for this case studies. So we have group plankton, fish, and whale. And then the group's chat logs are coded and then EIA were applied. So here are just examples of the codes for reasoning, how students are making claim and drawing on evidence to support the reasoning, how they're engaging in transactive exchange, building on prior ideas by themselves or their friends, and then how they're responding to the bot. So for the first question, we're looking at group conversations as a unit, and they're building subtraction networks with the group pairs. And then for the second question is looking at within student groups difference between the chatbot conditions, because each group is interacting with both bot. We're looking at individual students as the unit of analysis. So here's just an overview when you build the subtraction networks with ENA and you compare the different groups. The overarching pattern here that we see is that higher level groups like fish, the mixed group compared to the plankton group, low ability, or high ability compared to mixed ability, is that we see more connections between claim and transactive exchange, so building on self or building on others, and then reasoning and transactive exchange in the higher ability groups. Within group, when we look at the connection, like here's the example, right? So group plankton, which is a low ability group, is just giving simple linear connections, whereas group well high ability groups is also providing reasoning. For example, regulation increases fish, because it protects the fish from overfishing. And then within students group, when we compare the discussion patterns, we see that we did see, as we expected, some differences in how students responded to the expert versus the peer version. So the low ability groups showed more responsiveness or help seeking when they're building on self, responding to the bot when they're talking with the expert agent. In comparisons, the higher ability groups are showing more connections for making claim, responding to the bot reasoning, and transactive exchange in response to the peer bot. So showing more help giving to this less knowledgeable agent in this context. And then interestingly, we see a mixed pattern in the fish group. And then we also see at the points the individuals are closer together, showing less variance in how they're interacting. And so what all of this means is that, well, first, we have to ground these observations within the limitations of the study, meaning that we have a pretty small sample because it's case studies and students only interacted with each agent for about 12 minutes each. And then ability, as indicated by the pre-task, is just one dimension. Given those limitations, however, these studies still illuminating because it illustrates different interactive patterns between the groups. And then we see that instead of perhaps providing matches to similar time intervals or given certain words or key phrases in the chat, the need to provide adaptive scaffolds for students with different ability compositions, and also try to dynamically vary the support as groups advance their knowledge over time. The second takeaway is that we see that students in the lower ability group show more reasoning with the expert version versus those in the high ability group show more transactive exchange with the peer versions. And this parallels observations we see in one-on-one interactions, but it's still very interesting in this group composition context. And so it points to future need for design work to combine the agents or diversify the designs to support these heterogeneous group composition. And this is something that I'm actively researching for in my research. So I want to acknowledge my dissertation committee and my partner, Crystal Conservancy, and then I'll take questions after at the end of the presentation. If you have questions, please do put them in the chat, and thank you for your attention.
All right, thank you so much. So that was really great, and you did really well on time. So you're exactly on time. So that's very interesting. So just like she said, we will take the questions after all the presentations are done. So feel free to have it in the chat or just wait until we're done, and then we'll just have our questions. So we'll now dive straight into our next presentation by Anita and Reynolds, Teachers' Beliefs Shift Across Year-Long Professional Development, ENA Graphs Transformation of Privately Held Beliefs Over Time. Anita, the floor or the screen is yours.
Thank you. Can everyone see my screen? Okay. So my name's Dr. Anita M. Bana. I'm an associate professor of science education at Indiana University Northwest. My colleague was a secondary science undergraduate major who helped me over the last 2.5 to 3 years. The context is a town 50 miles southwest of Gary, Indiana, an urban elementary school. We can see here high minority and even higher free and reduced lunch. There were 3 novice kindergarten teachers, and the intervention was a year-long professional development centered on problem-based learning, or PBL. The theoretical frameworks are 2 areas: one, beliefs, teacher beliefs research, and then professional development initiatives. So in Thagard's coherence theory of justification, he talks about the fact that beliefs are held as a floating raft. And as one belief shifts and the raft tips, other beliefs try to right the raft by aligning or cohering with beliefs. If we add a new belief, what happens? They're in disequilibrium. What do? Do we dismiss an old belief, or do we modify the old belief to accept the new beliefs? My background was to take teacher beliefs research. There were decades, and the conundrum was always, which happens first? Do the teachers shift their practice or their beliefs? And so my research stated that actually the research supports that beliefs are entangled. They're so entangled, why should we try to tease them apart? So my previous research was about the fact that we hold beliefs of practice structures, and that those include three things: our professed beliefs, what we say; our intended beliefs, how we prepare, what we do in instruct, or what we think about before we instruct; and then our pedagogical beliefs are our classroom practice. That's the beliefs of practice structure that this study is framed around. Finally, Lou's work on critical reflection was one of the key factors in an extensive review of professional development literature that showed that teachers who actually engaged in critical reflection not only approved of the professional development, but actually implemented more transformation in their classroom. So the research questions: what aspect of sustained professional development encourage shift in beliefs of practice structure during implementation of PBL pedagogies? And how do beginning teachers' beliefs of practice structure change as they navigate this? I'm not able to move my slide.
Maybe, do you want to, maybe, yeah. That works.
Thank you. So the continuous critical reflection professional development model that we established was weekly pedagogical conversations. So once a week for an hour, we asked intentional questions regarding problem-based learning tenets, how teachers felt about students' capabilities, about problem-based learning, what they liked, what they didn't like, what they disagreed with, and those were audio taped and transcribed. During the cycle, we also engaged in peer mentoring and coaching. We established a trusting relationship so that during these pedagogical conversations, colleagues would share how they might have navigated something that another colleague was having trouble with in their classroom. We had an extreme classroom presence. 2 researchers observed 2 teachers per week during their 6-week units in fall and spring. We found shifts in pedagogical belief discussions, and we actually asked teachers to continually reflect upon the decisions they made in these weekly pedagogical conversations, the actions they took in the classroom, and then the outcomes of such actions. Again, classroom presence and observation completely filled in this cycle, and we continuously did this throughout the study. 3 major data sources. We had 3 major PD sessions, 1 before the school year began. Then the teachers enacted a 6-week PBL unit in the fall. Then we had a mid PD session that was a day and a half. Teachers did another 6-week unit in the spring, and we had a post professional development session in May. We had a problem-based learning questionnaire that talked about, what do you believe about problem-based learning? What do you agree with? What do you disagree with? What are the teachers' roles? What are the students' roles? That was given pre, mid, and post. And I talked about the pedagogical discussions. Quickly, we'll go through the codes. We spent about 8 months coding about 150 pages of transcribed data. And we started with open coding, and actually through many inter-rater reliabilities, started about 84% and ended the last couple of months between 90 and 100, in the last few weeks, 95 to 100% IRR compatibility. I'm going to talk about some of the codes, but some are intuitive. Teachers said that the students collaborate or they can't collaborate. I do want to talk about the Disequilibrium Code. It's an internal struggle to align or dismiss new beliefs that don't cohere. What we did was we created this code for any time that teachers spoke about conflicting beliefs in the same comment. Here's an example. They have trouble explaining what engineers do, but they know. But I don't think they know. But they know, but they can't do it. And another example is, I realize now that they can. Well, some can. Well, most can't. But I had kids tell the others that we're just wasting recess time. So right now, so they can. Other codes, these are listed in alphabetical order in case you're wondering. Students are engaged or they're not engaged. These are things that teachers thought and said and believed. Students are independent or not independent. They're motivated or not motivated. They actually had problem solving, can't reason as opposing beliefs. Either the students could problem solve and figure out something, or they can't reason, they're unable to think through the problem. Oops. So the second set of codes is process versus product, and the teachers either focused on the end product or the process of investigation by students. Teachers always felt that it was relevant, that they wanted something that was relevant to the students. And there are two conflicting codes called relinquish control and teacher directed. Teachers wanted to relinquish control, but teachers often used step-by-step directions. Student discourse was about whether they valued student-to-student talk and whether they understood it was social negotiation of meaning. Student ownership and keeper of the knowledge were two opposing codes that are related to relinquish control and teacher directed. One is from a teaching standpoint, the other is from a learning standpoint. Student ownership is that students' ideas drive the projects. Keeper of the knowledge is the teacher has the knowledge, they decide when and where to tell. Trust is something that is established, and we were able to show that they did. Let's see what E&A did with these codes. So here we see 4 quadrants, and because of E&A's ability to establish codes that are stationary, we can actually characterize these 4 quadrants as either positive PBL quadrants or negative PBL quadrants. So the teachers, 3 teachers, pre-graph, mean graph, actually it was situated in quadrant 3 here in the red. This quadrant is the most PBL negative quadrant with the following codes. It's about product. The students are not independent, they're not motivated, and it was about teacher directed. For the mid-mean graph, the teacher's graph fell in quadrant 2, which is the second most negative PBL quadrant. And here we find disequilibrium. I'm going to talk a lot about that, but what we see are conflicting codes. We see they can problem solve, but they can't reason. They can collaborate, but they can't collaborate. And they talk about engineering design as well. In the post, we find that it's found in quadrant 1, which is a positive PBL quadrant, and they believe that students are independent. They're questioning about their engagement here, but they start to value student discourse as a function of social negotiation. It's about the process now, and they're really attempting to relinquish control. We can see in quadrant 4, these codes are found in the teacher's individual graphs, but when we get the mean lands in quadrant 1, but the teachers, I'll show you, had believed in student ownership and relevancy. We'll see this more as we move on. So I want to share with you quickly, here's what happened throughout the study. This is the pre, and I'm going to show you pre, mid, post. Here we go. There's pre in quadrant 3, moving to mid in quadrant 2. Here's mid in quadrant 2. Here's mid to post, heading toward quadrant 1, and here's post in quadrant 1. Now let's look at the codes associated with that. This is the difference network graph, and we can see that in pre, teachers thought it was about the product, not the process. Students are not independent. They were teacher directed. Disequilibrium was there at the beginning of the study. Student ownership, they always believed in relevancy. They wanted to relinquish control. In the post, we can see that they shifted from quadrant 3 to quadrant 1, and now they believe that it's about the fact that students are independent, they can problem solve, they can collaborate. We see a little bit about whether they can't reason, but the strongest codes are collaborate to independent to student ownership. They now value student discourse. It's about the process, not the product. Students are engaged and they're really working hard at relinquishing control. So I want to talk about this because welcome to a new era. We have now visually displayed teachers' beliefs in disequilibrium. I do not believe it has ever happened before. This is the mid graph and this is the disequilibrium code. And let me tell you that this code is connected to every single other code except for one, which is that students are engaged. So they were conflicted about all codes in the mid and had disequilibrium about them all. So the discussion is what aspects of PD encouraged the shift? I would suggest it was those pedagogical negotiations in those weekly focus groups. constant classroom observations, coaching, mentoring, strong classroom presence, and what happened to those belief of practice structures, statistically significant difference pre to mid and pre to post. ENA did visually display disequilibrium for the first time. They do hold conflicting beliefs simultaneously. These all push the literature forward, including the fact that teachers shifted from PBL negative to PBL positive belief. Implications, maybe we should be looking at establishing trust, frequent classroom observations, and those pedagogical negotiations. They do hold conflicting beliefs, and let's look at those belief and practice structures as a whole. Future research, maybe we should ask, which beliefs do they keep? Which do they discard? Are new beliefs added? And can teachers hold conflicting beliefs aside from the disequilibrium stage? And then the two most important ones, can ENA be used to predict shifts in belief of practice structures? And can it be used to tailor professional development to teachers' beliefs and needs? Thank you so much.
Right. That was very, very interesting. Thank you so much, Anita. So it was
very fast too.
Also very fast. So too much and very interesting findings, and presented in a very quick way. So thank you so much, and we look forward to further discussion. There are already discussions going on in the chat, and I think Eric has some questions about the raft and the epistemic frame and all that kind of stuff. So just get ready. I think we'll get into that discussion after the next presentation. So our next presentation is by Kamuna G. Sorry, I don't have the other name. Sorry. Yeah. Guadalupe Kamuna. I hope I got that right. So welcome, and the floor is yours now. Please go on.
Thank you. And can everybody see the screen?
Yes.
Is this wait, the presentation?
Maybe just yeah.
Is the correct presentation mode, or should I switch?
That's the previous one.
All right. All right. Yep. Well, thank you very much to the conference organizers for allowing this space during this whole conference, which has been fascinating, and I'm fascinated by my previous presenters, and I have so many questions, but I'll move quickly because I have 10 minutes. So Beatriz and I will present today on behalf of the team at UTSA, who's exploring ENA, which we found has been a great contributor to our work in models and modeling. And we're presenting today an exploratory study where we used ENA as an analytic tool to help us better understand possible interactions and structural connections between computational thinking and critical thinking, as elicited in a type of task that we call model eliciting activity, which are open-ended, authentic tasks that are solved by students collaboratively. So to give a little bit of context of where this study is situated, this is part of a larger grant from Crest Center that NSF awarded to UTSA. That is at the Institute of Cybersecurity in the College of Sciences, but it's actually a collaboration between 4 colleges, including engineering, business, and College of Education. So we represent I'm co-PI on behalf of the College of Education, and we represent the education and outreach component of this project. And as part of the, you can see that the goals are closely connecting the innovative research that happens in terms of cybersecurity and cloud computing. And the idea is, how do we capture that knowledge as it's being developed by the experts, and we are able to translate that knowledge to help students become, a new generation of students become evolving experts in the field. So we're using innovative research-based educational strategies, and as part of the education and outreach component, we are co-developing with the largest school district in the San Antonio area curriculum for high school on cybersecurity and cloud computing. So within this curriculum, there are a type of activities that we use that we call model eliciting activities. So these activities are similar to case studies for kids. They are designed for students to work collaboratively in teams of 3 or 4. And they pose a problem or a challenge that a client has, and students are asked to create a solution for that client, perhaps by writing a letter where they explain the procedure to solve that particular problem. We use principles to design these tasks, and in the way that we design these tasks, the solution is actually a mathematical model that we intentionally design to elicit big ideas in STEM. So this is situated within a theoretical framework called Models and Modeling Perspectives, and I'm not going to go very thoroughly into this, but this is about situating or posing situations, like in the case of model eliciting activities, from the real world, so that students can mathematize those situations, making mathematical descriptions of those situations by creating those models, which sort of is in the opposite direction of more traditional problem solving, where a symbolically described situation is posed to students and they are asked to make meaning of that in the real world. So in the mathematization process, students, as they model, they are really taking the real life experiences and situations, mathematizing them to describe, to manipulate, to predict, verify from the real world to the model. From a models and modeling perspective, we define a model as a conceptual system that is embedded in multiple representational media and that is developed with a particular purpose. So we design the model eliciting activities to elicit, very intentionally elicit one big idea in the students' solutions. And so in the context of the CSPEC grant, one construct that is strongly relevant to our work in cybersecurity and cloud computing, of course, is computational thinking. And I don't think I have to mention a lot about the relevance, especially in the past probably 10 years of computational thinking that is now relevant from the K through 12 and beyond. And it's a foundational construct that is now considered part of literacy in the technology era of information. So these are our definitions for computational thinking and for critical thinking. So there's been some previous work that we've done where we've seen that critical thinking is very much part of that modeling process. And one thing that we were interested in looking at, especially in views of epistemic network analysis, is how do these two constructs relate to each other? What are the connections between the computational thinking and critical thinking? First of all, do they emerge in the activity that we designed? And secondly, what are the potential epistemic connections between these two? So our research question is, what is the structural relationship between computational thinking and critical thinking as both constructs emerge in the tic-tac-toe MEA? So the tic-tac-toe MEA is an activity that we designed where we provide a context, we relate to students what the Turing test is, and then within that context, we ask them to create an algorithm or a set of procedures that they can embed in a machine so that the machine plays versus a human and the machine never loses. So students need to construct the strategies or the procedures for the machine to never lose versus a human when they play tic-tac-toe. And you can see examples of what students' initial solutions might look like. We have found that quantitative ethnography has been a great contributor to this work as we've explored this possibility of. We had used discourse analysis in the past, especially in the context of model eliciting activities. Students take about 20 to 30 minutes to solve this activity. So the whole process of them coming up with a solution is very interesting to us in terms of how the constructs that we're interested about develop and emerge as they work collaboratively. We have done discourse analysis in the past from transcriptions, from video recordings or audio recordings, but we wanted to explore epistemic network analysis because we thought that this would more systematically and visually help us to study those connections among the cognitive elements. And so that's exactly what we wanted to do in the nature, considering the nature of the MEAs as complex problems that we're posing. So, Beatriz.
Thank you, Dr. So how did we work for the ENA model? We had 11 participants and we video recorded them. They solved the activity, the model eliciting activity. They worked on the tic-tac-toes. We recorded, and then after recording them, we transcribed it. We did the transcription. After that, we did the analysis of the transcription. And could you go to the next slide? How we did the coding and the analysis. We used analytical coding methods, and we used two coding schemes, one for critical thinking and one for computational thinking. We used initiation, exploration, solution, judgment, and resolution for critical thinking. And for computational thinking, we use the operational definition that it gives us decomposition, abstract patterns, and algorithms. And I'm going to give you some examples of them. So for initiation, we use the definition that it's an identification of a common question or problem. And one example that we had is, do we have to win every time? I kind of want to do that. And that was for the part of critical thinking. And for computational thinking, for example, in patterns, we use the definition finding similarities between items. And the example we took as a pattern is, I'd start in the corner here, these corners. So we coded in two separate coders with a binary coding, one being true when the characteristic was evident, like in the examples, and false if it was otherwise. If there was a difference between coding, we use social moderation to find an agreed upon code. And the units we used were participants or students within a team. So for this specific study, we focused on the teams because we wanted to know the results of the different teams we had. All lines are associated with a single value of a team. In the moving stanza, we had to try different moving stanzas. The standard is a 4 moving stanza, but given the context, which is high school students playing tic-tac-toe, we decided to use a 20-line. The relationship, the 20-line moving stanza. There is a relationship between what is said on the 20 lines, and the meaning is created in conversations greater than a 4-window stanza. So our optimal solution was with a 20-line window stanza.
So we analyzed the epistemic network analysis graphs based on the strength of the connections between the nodes, representing our operational definition for computational thinking and for critical thinking for each of teams 1, 2, and 3. And then we interpret the network models by the connections. So we noticed in the whole process that we could describe team one as trial and error. So they did a lot of tic-tac-toe games, and then they found their patterns from those trial and errors. Team two actually did sort of the opposite. They created rules, and then they tested those rules and then came up with some more general rules that were integrated. And then team three was more similar to team one, from particular examples to more general. However, we see that the networks, there were different ways in which they connected different elements of critical thinking or different elements of computational thinking. And then our research question, which was finding those connections between critical thinking and computational thinking. So for team one, the connections was more on the exploration and on the abstract. And they did a lot of exploration, which makes sense with the way that they approached the whole session. Team two, they did a lot of abstraction on computational thinking, which is strongly associated, of course, with modeling. And they connected critical thinking like resolution with judgment by the way of abstraction. So we can see that here. And then for team three, they did a lot of exploration and connecting with abstraction. So lots more to say. I will end in a minute. We also explored what some possible interpretations would be for the axes that were generated. We found that between the first two axes, they explain over 50% of the variance. So we felt that that was a good portrayal of what was happening with the teams. And we learned several things in terms of the context of the model eliciting activity and a research question we did see that computational thinking and critical thinking were both elicited and that they connected in the three teams. So this was sort of addressing construct validity of the task for us. We also saw that each of the three teams generated distinct concept spaces which characterize their cognitive processes, but those were embedded in sort of a similar structure in terms of computational thinking and critical thinking. And then lastly, exploration and abstraction appear to be key mediating components that facilitate the connections with other characteristics of critical thinking and computational thinking. So ENA has been a great contributor to our work. We anticipate exploring a lot more of this tool for our work in the future. And thank you.
Thank you so much, Guadalupe and Beatrice, for another interesting presentation. So look forward to further discussions after the last presentation. And if you have any questions again, just keep them or put them in the chat. So we'll go into straight to our last presentation by Eric and colleagues, peering a generation into the future, assessing workforce outcomes in the 2020s from an intervention in the 1990s. This is interesting.
Thank you, Rogers, and I appreciate all of the conversations and presentations so far. This has been just great. This talk shifts a little in that it looks and makes carries out research that assesses retroactively or retrospectively a program that the National Science Foundation spent a lot of time and money on in the 1990s. It's quite relevant now as we look at ways that we diversify and expand the workforce, because those were the goals at the time of a program called the Young Scholars Program in the 1990s. What we want to do in this project is assess what happened to the individuals who were in middle school and high school during this program. It was designed to help promote or foster their interest in STEM careers. Well, did it have an effect? And are there any lessons that might be useful from a policy standpoint now? In fact, there are many critical policy issues related to workforce development, and looking at investments that NSF made earlier, we conjecture can be very helpful. So Sung, do you want to go on to the next one? I'm going to be very quick with an introduction, and then Sung will go into some of our early data. So we had at NSF a program that was specifically targeting high achievement students, but it was really a broader span of students. There wasn't really so many filters in that. And it actually started when NSF began renewed funding of pre-college science education in the late 1980s. So the students at that time were grade 7 to 12. There were about 18,000 students, we estimate, although there was never any census made of those students, but about 18,000, and they're all in the age range of around 40 to 52 right now. So if you are investing as an agency a large amount of money in things like the iTest program or AZEL, and you're trying to see what the best way is to have an impact on the future of workforce, we're in a position to try to see what happened last time there was a huge effort like this. Go ahead, Sung. At the time, there was a lot of public interest in the program. This is one at Cornell University. We had a television program, an ABC special on a program. I was in the Young Scholars program running the very first batch. There was ABC did a special on it. We had a special presentation with the mayor. This was common across the country. Okay, so keep going. So our goals, I won't read all these, but we want the things that you want with students. And some of these have been articulated so nicely in the last couple of presentations about ways that you'd like to engage students, develop their critical thinking, develop what we now call computational thinking, case-based reasoning, model eliciting activities, problem-based learning. These all did not have, were not all fleshed out, but these were the kinds of things that we were looking at. And also to get kids to think differently about themselves. This was a program that in some ways implicitly dealt with identity formation. A student thinking about, do I belong on a college campus? Because they find themselves on a college campus for the first time. So we want to increase their ability to make career decisions. Keep going. So our aim is to assess the actual impact. How many of those kids actually went into science and engineering fields? Well, that's a great question, and originated through interest at NSF and trying to understand that and see how their career trajectories actually worked out. At the time, there was not a specific target of Black, Latinx, Native American, and female individuals, though most of the principal investigators did have that priority interest. Keep going, Sung. So our overall approach, we've been contacting PIs, the ones that are still alive, but also the alums, and collecting data from surveys and interviews, and then applying QE and ENA to those interviews using social cognitive career theory, interest-driven creator theory, trying to understand how what we're in the chat window talking about epistemic frames, how frames shifted in ways that might accommodate young learners possibly going into STEM fields or being informed about future career options and opting not. Sung, it's over to you.
Okay, thank you so much, Eric. And so for this particular paper that we're presenting today, we were looking at the interviews that we conducted with project directors or the principal investigators. And the one question that comes up is, why do we look at PI interviews? And one of the reasons was that the focus on the PI, we did it because they're instrumental to the design and operation of each individual project. And for us to get a good grasp of the YSP, we needed to account for their intent and their approaches. And another key reason was that actually their contact information was readily available on the NSF grants database. And they actually became the starting point for our search for the YSP alums. And so they were our first contacts. So we conducted 12 semi-structured interviews. We collected information on project designs, especially in terms of their recruitment and selection, and also the types of activities and experiences that were offered. And we also had some questions on the perceived impact of the project on not only the alums, but the PIs themselves and the host institutions. So this is a table of the 12 PIs that we interviewed. So as we can see, the sample includes a mix of gender and also a mix of areas of expertise and geographic locations. For the most part, they were with public institutions, and most of their programs were residential in format. So going over to this is our code, part of our code book. So we, based on a grounded analysis of the data, we identified 9 key constructs, which we use as codes. Those codes we grouped into 3 main categories of recruitment, design, and student impact. So I'll kind of talk through those. So in terms of the category for recruitment, we had codes for high achievement students when they were explicit that they were looking for high achieving students to participate. Also, we had a code for underrepresented groups. Again, when the PIs mentioned that they were recruiting specifically participants from underrepresented groups. And in the design category, we had a code for multi-stakeholder collaboration when they discussed aspects of collaborating across disciplines, across departments, with teachers, etc. And we also had a code for research integration. Some PIs explicitly wanted students to come join the research that they were doing. And so that was part of an activity set in some of the projects. STEM field exposure, where curriculum focused on exposing students to different parts or different elements, aspects of STEM and affiliated careers. And we also had a code called College Student Mentors. Some of the programs actually utilize undergrads and grads in the programs as mentors, diverse experiences. So in these programs, not only did they have curriculum around STEM, they also had different social types of events, field trips. So those were categorized or those were coded with diverse experiences. Now, going on to the category of student impact, we had a code for academic motivation, where in looking at student impact, these are actual perceived outcomes. So when the PIs felt that the programs actually motivate the students to pursue or to more deeply engage in STEM areas, and also influence on student path when they felt that participation in the program actually made a difference in the trajectory of the students. So we, again, very similar to the other studies that were presented, we transcribed the data, we coded it. Inter-rater reliability, for inter-rater reliability, we went with social moderation. In building out the models, we used individual turn of talk during the interviews as the unit. And in terms of the conversation, we also utilized the utterances that were associated with the same topical question. And so in the connections, we made across the entire conversation. So this is the overall discourse pattern that were exhibited by the 12 PIs. What we are seeing here is that STEM field exposure is quite central to the design and the perceived outcomes of the YSP projects for these 12 PIs. And we see some strong connections between STEM field exposure and a number of other codes here. And we'll go through several of them here with qualitative examples. So the first connection we want to see is STEM field exposure and diverse experience. So so as I was mentioning, not only did the students have a curriculum that was really intensely focused on STEM areas, they had these other experiences. And PI number 7 here is talking about the fact that they had a variety of field trips almost every weekend, and that they would get scientists and engineers to come and speak with the students to provide a conceptual, to provide the conceptual underpinnings. Now, moving on to the connection between STEM field exposure and academic motivation. So this particular PI, he was interested in involving students in his actual research lab. And so this is along with what we were coding also as research integration. But in the course of in the course of participation in the WISE program, he talks about how at some point we had students aspiring to be Westinghouse winners. And actually, he did mention that one of them did actually become a Westinghouse winner. Looking at
sorry. Could you kindly summarize, like in
yes,
2 minutes?
Yes. So yes. So perhaps I can. Yeah. Thank you. So these are some additional qualitative examples of the structures. We were also interested in looking at the structure of connections for the individuals, and so this right now we're seeing the means of the plotted points for each of the 12 individuals. They're fairly clustered together. We wanted to be able to see the differences in the structures. We kind of focused on the ones at the outer edges, and we can kind of see how the structures are different. And statistically, we are also able to find that those ones on the outer edges were also quite did have statistical differences in their locations. All right, so going into the sort of what do we learn from this? I guess one main thing is that the analysis indicates a diversity in the design and delivery of these projects, and we also found that providing exposure to different STEM fields was a central feature of the projects. And in this process, diverse activities were organized to increase interest and motivation for the students. Limitations of the study include the fact that the PI interviews can only shed light on what they perceive to be the outcomes. And so we are currently we're interviewing the YSP alums themselves to be able to see what those actual outcomes are. And also, again, because of the fact that we are following up on something that happened 20, 30 years ago, there are difficulties in identifying and reaching out to the PIs and the participants. And so therefore, there's an issue of selection bias where, those people who are reaching out to us, they are they doing so because they probably had a very good experience in the project. And so our last slide was, yes, so we are now engaging in collecting data from the alums themselves. And we're also thinking about looking at the PI interview data in a different way to perhaps get a better sense of how it impacted the PIs themselves and the host institutions. Thank you so much.
Great. Thank you so much, Son and Eric, for another interesting presentation. And I think it's time. I mean, we have had very interesting discussions. It was very hard to cut them short because all the presentations are really interesting. I hope we can possibly have at least 10, 15 minutes to have a quick discussion and some questions from the participants, starting from maybe first things first. We had a discussion between Eric and Anita. I mean, you responded to some of that, but I don't know whether Eric wants to clarify on a question or you want to extend a little bit on what you were talking about so that Anita can everybody can possibly benefit from the discussion.
Thanks, Rogers. I so appreciated watching the transitions from beginning, middle to end. And I think that's very important for the QE and ENA community to be able to make those visualizations. The conversation was about the construct of an epistemic frame. I interpreted Anita's outline or sharing of the raft as being an analog or a metaphor for the epistemic, for a notion of epistemic frame. In our work, we're trying to look at epistemic frames as how kids view the entire possibility of becoming in those careers. But I really liked watching how epistemic frames were represented to have adjusted over the course of the PD. So thank you, Anita. I don't know if anyone else had a comment about that, but I thought it was quite compelling.
Right. Can you unmute, Anita? Yeah.
I just wanted to share something really quickly. So those pedagogical conversations were key. It was instrumental in them deciding to shift some of the beliefs they held. I want to give you a quick example. Remember, these are kindergarten teachers, so they're teaching kindergartners. So one of the teachers came to the pedagogical conversations and said, I'm having a problem. After recess, the kids are on the rug and they're not listening to me and they're touching each other and playing with each other. And I said, how big is the rug and how many students? And when she told me, I said, of course they're doing that. What if you took them and paired them up around the room and asked them to talk about something in, let's say, I just made something up, grown-up groups. So she said, I'm going to try that next week. So she goes and she does it. And then she comes back the following Friday. And I said, how'd it go? And she goes, well, on day one, I paired them up and I placed them all around the room. And when I was done, I looked around and they were all rolling all around the room. And then she said, but day two, that was so significant because teachers don't continue shifts in practice depending on students' reactions. And she continued, she said, day two, I made them sit knee to knee. They didn't talk. But on day three, someone said something to someone else. And on day four, they talked back and forth. And on day five, they were actually talking about what they were supposed to. So this is key in that we are able to display through E&A their shift in their belief structure as they implemented things that really teachers don't continue with. And it actually inspired the other teachers to keep trying, even if the students didn't do something the first time.
Interesting stuff. I don't know whether I don't know whether David wants to continue on the same path. Maybe you can go on, please.
No, I was going to ask about something different. So if somebody wants to continue on the same path, I'm happy to yield the floor.
Yeah, there was a question from Barbara. I don't know whether Barbara you want to come first and then we go to David before we go to someone else.
Hi, thank you, Anita, for your wonderful presentation. It was great to hear. So I was just wondering whether you had any perspective, and I know it wasn't within the scope of your research, whether you had any perspective of sort of understanding of maybe the way the teachers were connected or networked within their organization, and maybe the culture and how it had an effect on how readily they were accepting the sort of shift in their beliefs.
That's a really good question. And I'm not muted. That's a really good question. And we know that that when the longer we hold beliefs, the more reticent we are to give them up. And so the teacher beliefs research says you really can't talk to new teachers about their beliefs because they're struggling with classroom management and all these things. And I thought, if you tell me I can't, I'm going to. And so I worked with the kindergarten teachers. They had new beliefs. And I believe, Barbara, that possibly because they weren't sure about those beliefs, they hadn't held them for 10 or 15 years. We did research for 4 years with each year a different group. And teachers who have been teaching for more years were more reticent to give up their beliefs. But specifically to your question, Barbara, it was a new tech school that was project-based learning. But that was the principal's view. The teachers had other stories, but yes, it was part of their framework.
Thank you.
All right, David, please.
Yeah, so first of all, I thought those were 4 great presentations. And one of the things that I enjoy about a session like this is actually seeing, so many different topics that sort of converge around a particular methodology. And I guess one of the things that I'm wondering is sort of for each of you, what's the affordance of doing this with ENA? Is that it shows you something? Is that it helps communicate with an external audience? Right here, it's sort of easy. It's the ICQE conference, and so we did some ENA, and so we'll show you that. But I'm wondering, outside of this context, what's the value proposition for you, as you're thinking about using this rather than any other way you could think about the data?
Well, I can share first if you want. Beliefs are held privately, and there aren't measures that can actually measure beliefs well. And ENA is able to do it because of the fact that you can take multiple data sources where you have conversations that you transcribe and encode, but also you have written assessments at different points in the study, and you use the binary coding, and then it can actually show what the teachers are believing. And it just isn't, I can't do it any other way.
Interesting. Any other reflections from other presenters on the same question?
I think it's a conjecture that the visual models can tell us something that we didn't know, and that's why one thing I was so pleased to see the models in the other presentations, and for Anita to show those shifts. We are making a conjecture that we can identify what one kind of epistemic frame pattern looks like and how it might shift to greater openness. And we might be wrong, but so far we think we're getting some palpable pictures. I don't know if you can say a picture is palpable, but do some synesthesia or something. But I think there's an added value, but it is a conjecture. We think it's a pretty good one, but time will tell.
Yeah, I agree. And in terms of what we're trying to assess, these are really complex dynamics that we're trying to examine here. And we're finding that even more so with our interviews with the actual participants, because we're trying to assess their academic and career trajectories, the decisions that they're making. And so to be able to not only identify those key elements, but the structure of how they relate, I think ENA is just made for that. So
maybe not to, before we go to someone else, I just wanted to actually, yes, like you said, it was really a complex process, like for your project, Eric, and so on. And I realized that you had, when you were coding, you had these two, you had these like social cognitive career theory and interest-driven creator theories, which I think are very interesting theories. But when you came to the actual interpretation of the coding process, you actually went through a grounded approach. I thought the theories were going to help you through that process. Any ideas why you took the other approach to looking through this data?
Yeah, so
go ahead, son. Yeah.
Yeah, so the theories that were sort of shared in the beginning, that they apply to the entire study. So I probably, because of the fact that right now with the PIs, we're only assessing sort of these perceived outcomes. And so we can't directly apply as the social cognitive career theory, the framework to that data, because so when we actually, exactly. So we'll be applying them more to the data that we collect from the students.
Okay, can we hear from maybe the other presenters first? Reflect on David's question and how you see what ENA is actually providing. What is extra that you can actually see with ENA, not the other approaches possibly around?
I think several things, but I'll mention a couple. One is being able to systematically analyze something or the cognitive structures and visualizing those connections and being able to tell a story with the visualization. So it's not only that, you know, when we have those transcripts, conveying what happened is very complex. First, it's very complex to analyze that systematically and rigorously through discourse analysis, but then conveying that to a broader audience who is not as familiar with the context is really complex. So that would be one thing. And then the second one, I would say, being able to portray the dynamic nature. So it's not only the connections, but also the dynamic nature of how those connections are formed. And we didn't present that here, but we are exploring those trajectories now in the modeling episode to look at that dynamic, at those dynamic processes. So being able to visualize the diversity in thinking, but at the same time, the convergence of a certain cognitive structure amongst different ways of thinking.
And I think that was really, very interesting. Yes, Beatrice, please.
Sorry, just to add, like being in a interdisciplinary grant, it is very important for the computer science and the engineering, and I think they relate to the math and to the visualization much better, much easier, or it's more common to them. So having this tool to talk to them, I think it's also very, very useful for us.
And I also realized through your coding, I mean, the concept of computational thinking and critical thinking, there is a lot of thinking for both concepts, and of course the definition of computational thinking. I mean, you clarified it in the paper, but I was also reflecting on how you actually went about the process of coding and differentiating between what computational thinking is and critical thinking. Of course, you had a very interesting code book and some kind of frameworks to actually guide you through the process. But I'm wondering whether during the process, do you have any kind of overlaps or any kind of challenges in actually finding things which you think is this? For example, when you define here, you talked about computational thinking as considered as the highest order of problem solving, right? And also under critical thinking, one of the things is, one of the features of critical thinking is an aspect of higher order understanding, which is highly regarded, of course. So both aspects would actually somehow overlap. I don't know whether you had challenges with that when you are trying to label these kind of activities and actions as either critical thinking or computational thinking.
Yeah, that's a really good question. I guess that's how we first decided on which constructs we picked, because we had done some work on critical thinking and how that was elicited through the model eliciting activities. But critical thinking is a term that has been used for 100 years since Dewey. And so this has been evolving. Ennis then talks a lot about critical thinking. And now we have this new term called computational thinking. So I guess an underlying question that we didn't make explicit is, what is that overlap between critical thinking, which has been operationally defined for over 100 years, as something, as a type of higher order thinking that is sought for literacy and for enacting with the world, and this new term of critical thinking. What is the critical thinking adding sort of to critical thinking?
Okay, any other questions from the audience to the participants? I don't know whether you want to share or to answer or respond to David's question in line with your research.
I mean, I think the other
What are you
say it beautifully, but what I will add is, just the flexibility to change your analysis level, for example, in my case, with emphasis between the conditions, and also to be able to pinpoint the notes and then go back to my data to actually see what is happening.
Yeah, and I mean, it was very interesting to see how you seeing the different groups you had, like the low ability and the high ability. And I think you touched this in the limitations, but I mean, I was wondering, I'm not criticizing this, but of course you had this pre-test pre-test which you used to actually categorize the students into 3 groups, right? Of course, before you presented the limitation, I realized you touched it. That was good that you actually aware of that. But of course, at some point, someone could say, okay, is this enough? Is this actually just a test? And then you categorize and then you base all the analysis on that. But if you are to do this, I mean, if you are to overcome this, like what kind of ways would you think about to come up with a concrete kind of groups that can actually help you in modeling the different behaviors across the different groups?
I think the longer term vision of this is touch on a little bit, so we can have a baseline assessment like a pretest or something when they start the conversation. But as they continue building on it, we're still keeping track of what they're talking about and keeping track of their like current knowledge state for each individuals in the groups. And so even that categorization can change over time, even within the conversation. So that I think would be a more adaptive, inclusive response to your question.
Sure. Yes, Masha.
Hi, thank you all for the great presentations. So in line with Roger's question, would you consider mixing the groups by their ability? And if you do so, how do you intend to use the different agents?
This is something that I'm still exploring. So like this pilot for this year is we're going to have the pretest and then really assign them to these groups that mix in high and low. And then with a larger sample, and we're going to see whether the case studies examples are going to generalize. And then if, you know, you talk to me next year, I may have a better answer to that question of how that interactions play out.
Yeah, any other questions? I think we have we are quite over the time. Maybe we'll, if we don't have any other questions, I mean, we can continue the chatting, and we have community chats coming next, so it's already going on. We can always reach out to different participants. But maybe one thing before, Anita, I realized you had 4 different types of data. I don't know whether it was 4. You had some data from focus groups and surveys and interviews. How did that work? Like in terms of, and you had some data which did you use everything from different sources of data, and how was that experience?
Yeah, that was interesting. I think we had 8 or 9 different data sources, but the major data sources I described, the first the only data source we could use was their responses before the study began on 2 assessments, their beliefs about problem-based learning and their beliefs about ways that they would, how they teach, whether they, what's the student's role, the teacher's role in problem-based learning, what are benefits, what are weaknesses, those kinds of things. And so the first graph was only that, but after that, it included all the data sources, revisiting that source as well as all the observations, classroom observations, the notes from that, the pedagogical conversations that were then analyzed. So the data sources increased after the but we weren't able to do anything else but those 2 written data sources for the yeah, so it was a lot of data sources and it took over 8 months to analyze. I might try the next study I do, doing it, working with a partner, but then using encoder and comparing the results. That might actually be a good study because I'm interested in working with encoder with the data challenge. I'm interested in seeing how can we compare those, and are they similar? I think that's interesting. So
I think that would be a good validation study of encoder and the approach you took. I think it will be really interesting. Okay, very interesting. But as I said, thank you so much for coming to this session. It was very interesting, and that's why we spent a long time, but nobody left. So we have been here for all this time. So all the best with the next session. So we have community chat and a few other sessions, and I look forward to seeing you all, and have a good, I don't know, afternoon, morning, good evening, wherever you are. It's coming to 7 p.m. here in Oslo. So I'll see you later in other sessions.